Hello, my name is Pamela Kuther, and I am an instructional specialist for secondary mathematics with Richmond Public Schools. Welcome to the Richmond Public Schools Distance Learning Modules. In this series, we will learn geometry, where we will have a different focus each week. This week, our focus is SOL G.8a, the Pythagorean theorem. Today, we will review how to write Pythagorean theorem answers as simplified radicals. Before we get started, you will need a few supplies. Your interactive notebook or a few sheets of paper, a pencil or other writing utensil, and your Desmos graphing calculator. Here are the answers to yesterday's practice problems. Please take time to check your answers and make any corrections. In the first problem, we need to solve for C. We know that C is the hypotenuse and 12 and 9 are the legs. C is across from the 90-degree angle, so that's how we know that that is the hypotenuse. And 12 and 9 are the legs because those are the sides that form the right angle. So I'll start by writing my formula. That's always our first step. And then I'm going to plug in the values. Remember that 12 and 9 are both legs, so they could be A or B. And C is the hypotenuse, so we're always going to plug in C squared by itself. Now I'm ready to solve. So my first step would be to square those numbers. 12 squared is 144, and 9 squared is 81. My next step would be to add those numbers together. And then, of course, my last step would be to take the square root of each side. And so my answer is C equals 15. Now in problem 2, I look at the sets of triangle sides and I need to determine if those three sides could form a right triangle. So to simplify this, we will use the converse of the Pythagorean theorem, which we discussed on yesterday. And that tells us that if these numbers fit into the Pythagorean theorem, meaning that they give us an equal equation at the end, then those three sides form a right triangle. 4 and 5, I'm plugging in for A and B because smaller numbers, not because they came first, but simply because they are the smallest two numbers. The largest number has to be C because the hypotenuse is the longest side. So I'm going to go ahead and square those numbers. And then I'm going to add on the left side to see if it equals what's on the right. So 41 is not equal to 36, so the answer here is no. So I'm going to go ahead and cross those out. Those three sides do not form a right triangle. And I'm going to follow the same process for the second set. 15 has to be my hypotenuse because it is the largest number. And the other two sides, 5 and 12, are the legs. And so I'm just going to continue to simplify to see if the left side equals the right. These sides are not equal, so again I will say no and go ahead and cross those sides out. Remember, 8 and 10 are the legs because they are the two smaller sides. The hypotenuse has to be the longest side or the largest number. So this set doesn't work either. So we know the last set has to be our correct answer, but let's just go ahead and plug those in so that we can see what a correct answer looks like. Okay, I'm going to go ahead and add those sides. And I get 841 equals 841. That is a true statement. And so my answer here is yes. And so this is my correct answer. Those three sides form a right triangle. It's a lot of work, but most of that computation can be done in your calculator. So now we're going to look at number 3. Now number 3 gave us a diagram, but I have to draw it out on my paper. So just bear with me while I draw this out. And so we can see we have a right triangle for my diagram. We have a ladder leaning on against the side of a building. That's a very popular Pythagorean theorem problem. So 8 and x are my legs because they form the right angle. 17 is across from the right angle, or it's slanted, however you want to look at it. But that is the hypotenuse. So I'm going to square the sides. And then I'm going to subtract, because remember I'm trying to get x by itself. So I need to subtract to move that 64 over. So I'm going to get x squared equals 125. And then my last step is to take the square root of each side. Now, I'm going to show you a process that we're going to learn more about today, but it looks at your answer. Instead of writing it as a decimal, we're going to write it as a simplified radical or a simplified square root. So here, and again, you're going to learn more about this process today, but here I am taking my 125 and doing a factor tree. And because it's the square root, I'm looking for groups of 2 numbers that are the same. And so here you can see I have a pair of 5s, so I'm going to circle those. So I'm going to take 1 5 out of the square root and leave that other one under there because it doesn't have anything to pair with it. So my answer here is x equals 5 square root of 5. Now, if you had a decimal answer, then you would have had 11.18 as your decimal answer. 11.18. Okay. So now we're ready for our instructional video. Please make sure you download the notes. Also make sure to copy and complete the notes, fill in the blanks as you watch the video. The video is linked in the presentation. And when you're done watching the video and completing the notes, you may come back to this presentation. Now that you've learned our skill for today, let's look at some model examples. So you learned how to simplify radicals. And so that's really what we're doing new today. We are going to do this in conjunction with doing the Pythagorean theorem. So the main thing that we're learning new today is how to write our answers in a different format. Up until this point, any square root that did not simplify to an integer or whole number, we wrote as a decimal. Today, we're going to write them as simplified radicals. So if you can go ahead and draw the illustration for model example number 1, and then we'll look at that solution. Okay, you should have that drawn. Now, again, when we look at the solution, the solving is exactly the same as what we've been doing. The only thing new here is how we're going to write our answer. We're going to write it as a simplified radical, not as a decimal. So we're going to follow the same steps that we've been following all week, writing our formula out first, a squared plus b squared equals c squared. And then I'm going to plug in my numbers. So I know 4 and 8 are my legs because they form the 90-degree angle. And then I'm going to square those. So I have 4 squared is 16 and 8 squared is 64. My next step is to add those. So I get x squared equals 80. Now I think we know 80 is not a perfect square. And so therefore I need to write this one as a simplified radical. So I'm going to go over to the side just to do some work. I'm going to draw my factor tree, just like was done in your video. So I'm going to start with 2. You always want to try to start with the prime factor because that'll make it easier. So then that branch is done. So I'm going to circle my prime factors so that I know that I'm done expanding that number. And you can see I continue to expand out. As long as the number has factors other than 1 in itself, I can just keep on factoring. So now I have all my prime factors. So I'm going to rewrite 80 with all of my prime factors. And remember, this is square root. The index is a 2, so I'm looking for pairs of numbers that are the same. Pairs 2. You probably learned last year in algebra about cube roots. That's groups of 3. Square roots, groups of 2. For every group of 2, I can take that number outside of the radical. So I have 2 2's that I can take out of the radical. So notice I've taken those out. The 5 is left under because it doesn't have anything to pair with it. And so both of those numbers are outside, so I can multiply them. And so my final answer is 4 square root of 5. Let's look at the next example. Now in this example, you have to draw a diagram. So I'm going to give you a minute or so to read the problem and draw yourself a diagram. Okay, so it doesn't have to be artist quality. You want to have a building, the ladder leaning against it, so that you want to be able to see your right triangle. So let's look at the solution. So I'm going to draw my rough sketch. Again, your picture just has to be good enough for you to be able to see the right triangle. I have my building, I have my ladder. The problem told me that my ladder is 5 feet away from the building, the base of my ladder, and that my ladder was 14 feet long. So I'm trying to figure out how high up on the building is my ladder going to go. So I'm going to go ahead and write out my formula. I'm going to plug in my values. 5 is one of the legs, so I'm going to plug that in for B, and 14 is the hypotenuse, so I'm going to plug that in for C. And I'm going to go ahead and square my numbers. Everyone should be able to zoom through this because we've done this for the past few days. And after I square my numbers, I need to subtract 25 because I want to get x by itself. And then my last step would be to take the square root of each side. And so now I know 171 is not a perfect square. And so I'm going to need to simplify this radical. And you may be asking, how did I know to start with 3? Well, I'm thinking about numbers that when they multiply times something else, they get something with a 1 on the end. So for instance, I know 3 times 7 is 21. So I know 3 times something with a 7 on the end is going to give me a 1 on the end of that 171. So that's kind of what I'm thinking about. Or you could just simply start trying to divide starting with 2. So I have a pair of 3s, so I can take a 3 out. And the 17 has to stay under because it doesn't have anything to go with. So there's my final answer, 3 times the square root of 17. And that concludes our lesson for today. During your remaining work time, please complete the practice set. Please complete the practice activity as well as the online practice. Remember, the answers for today's practice problems will be included in tomorrow's module. Enjoy the rest of your day and be safe.